Collaborative secure software development support indicates that the secondary developer deploys APIs based on mature products provided by the first developer to expand features and speed up the development of a certain type of product. For example, the first developer provides fingerprint identification algorithm library, such that the secondary developer can use it for the applications of door lock, car lock, and access control system, and so on. Next, this video will talk about the concept of collaborative secure software development support with the ARM Trust Zone technology and introduce the precautions of development flow and environment setup that first and secondary developer must pay attention to with the Kyle MDK ARM environment. Under the ARM Trust Zone environment, Flash Memory Controller provides the secure and non-secure world with secure region and non-secure region respectively. In the M2351 series, there are non-secure regions which can be dominated by the secondary developer and secure regions which cannot be dominated by the secondary developer. In the secure region, the first developer partitions a block used to place library, and the secondary developer can only call and execute the APIs in this block by non-secure callable instruction. The first development flow is mainly divided into 3 stages, including before, in, and after development. Before development, the first developers must set up a project and check if the software model is in secure mode, and then they can develop the project program. After development, the first developer must open SCRLOCK to protect secure code. The following will have a detailed description of each development stage. Firstly, before development. Please open Secure Project in the M2351 Collaborative Secure Software Development Support LED sample code. In the Kyle environment, open Options for Target. Click Target, and you can check if software model is in secure mode under code generation. Then, click Linker and specify the secure AP-ROM and SRAM base address in the RO base and RW base respectively. Edit secure script component file in scatter file, which is used to define the range of secure AP-ROM, secure SRAM, and placing non-secure callable APIs. Finally, specify a path to save the object file generated by non-secure callable provided to the secondary developer in MIS controls. After finishing setup above, the first developer can start to develop. In development, the first developer must configure security attributions. For example, the size of SRAM, the setup of non-secure region starting address, and the secure or non-secure configuration of peripheral and interrupt. In addition, the first developer must use non-secure callable to pack APIs built in the peripheral that secure configure to non-secure use. The above mentioned about the environment setup and the usage of non-secure callable with the first developer before or in development, please refer to Trust Zone programming document for details. In the final development stage, the first developer must open SCRLOCK to avoid code from being tampered or destroyed in secure region. And the secondary developer can only use library in secure region by calling non-secure callable functions, but cannot know or rewrite code in secure region. So, what is SCRLOCK? SCRLOCK means secure region lock. If SCRLOCK address isn't read as 0x5A, when the MCU detects there is ICE connected, the MCU will start read and write protection mechanism. Namely, user can only read all F in 32-bit hexadecimal register through ICE in secure region, and all program to secure region will be ignored. Additionally, the size of secure and non-secure regions are determined by the set value of non-secure boundary value. Consequently, the range of non-secure region the secondary developers are able to develop is from non-secure region starting address to the AP-ROM size. Also, in the CAL environment and secure project, open options for target. Click Utilities and click Settings button to open Flash download page. And then click Setting button under Chip Setting to open Secure Setting page. Because chip will do erase when setting up the non-secure region starting address. If the first developers don't set up non-secure region starting address through the program, they must take non-secure region, specify the starting address, and click OK on this page before downloading subsequent developing code. Also, when development is completed, they need to click Options for Target, Utilities, Settings, Setting button under Chip Setting to return to this page to take Secure Region Lock, and click OK to lock Secure Region. At last, the first developers must pack the following information to the secondary developers when they complete development. When the secondary developers are able to develop, including non-secure AP-ROM and SRAM base address, the object file generated by non-secure callable and non-secure callable library. So far, after you have the preliminary concept of first development flow, now, I'll introduce the collaborative development flow, which is also mainly divided into 3 stages, including before, in, and after development. Before development, the secondary developer must first set up project and check if the software model is in non-secure mode, and then develop the project program. After development, the secondary developer can open SCRLOCK to protect source code. The following will have a detailed description of each development stage. Firstly, before development, please open non-secure project in the M2351 Collaborative Secure Software Development Support LED sample code. In the CAL environment, open Options for Target. Click Target, and you can check if software model is in non-secure mode under code generation. Then, click Linker according to information of non-secure AP-ROM and SRAM base address provided by the first developer. The secondary developer must specify the data in RO base and RW base respectively. Click Utilities and then click Settings button to open Flash download page. The secondary developer must check if Flash Select has been set to AP-ROM NS and specify the SRAM base address in the Start field of RAM of algorithm and then click OK. Finally, open Manage Project Items and click Add Files to add an object file provided by the first developer to this project. Then the secondary developer can start to develop. When the secondary developer is in development, it can develop the peripheral that is configured to non-secure by the first developer directly, and can only access the peripheral that's secure configured by calling non-secure callable function when user wants to use or control it. In the M2351, for instance, the clock controller is fixed to secure-only peripheral, if non-secure callable library doesn't contain the function of clock source select provided by the first developer. The clock of the peripheral that the secondary developer wants to develop can only operate in the setup already configured by the first developer in advance. In addition, because the first developer protects secure region code by using SCRLOCK, the secondary developer will have the restrictions on access when debugging. In the non-secure project, please click Start Debug Session. For example, in the M2351, the secure peripheral is configured at the beginning address of 0x4, and the non-secure peripheral is configured at the beginning address of 0x5. The secondary developer cannot access secure region directly. Hence, user can only read the value of 0x8f and cannot write any value to control register in all address at the beginning address of 0x4. At last, AR-lock can be enabled after the secondary developer completes the product development stage. This prevents code in product from being invaded to get or tampered in any way by people with bad intention. All region lock implies that it will lock code in all regions. When the MCU detects there is ICE connected, if AR-lock address isn't read as 0x5a, the MCU will start read and write protection mechanism on secure region and non-secure region. The method of opening AR-lock is also in the Kyle environment and non-secure project. Open Options for Target. Click Utilities and click Settings button to open Flash download page, and then click Setting button under Chip Setting to open Secure Setting page. Just tick All Region Lock and click OK, then secure and non-secure regions can be locked, and the secondary development is finished. According to the introduction above, the first developer must engage in development under the project environment in secure mode. After the development is completed, the first developer must provide a secondary developer with non-secure AP-ROM and SRAM base address. The object file generated by non-secure callable and non-secure callable library. The secondary developer must engage in development under the project environment in non-secure mode. Note that when developed, the peripheral configured to non-secure by the first developer can be accessed directly. Otherwise, only the peripheral configured to secure can be accessed by calling the non-secure callable function provided by the first developer.